good afternoon. It's a pleasure to welcome you to another Zangwill seminar. Today we have the honor of hosting an expert in neuroscience of spatial cognition and memory, Professor Hugo Spiers from the Department of Experimental Psychology at UCL. Hugo earned his PhD from UCL under Neil Burgess and John O'Keefe. Following this, he completed postdoctoral research at the MRC CBU and at the Wellcome Trust Center for the Neuroimaging, where I had the pleasure of meeting him and even sharing a long desk for...
Oh, sorry. Can you use microphone?
Oh, yeah,
of course.
Of course, yeah. Very happy to get one of these set up.
You can just hang it on your
Yeah. Is that now working? Yes. I think I heard it. Yep. Okay. Yeah, thank you very much, Deborah, for inviting me to give this talk, and thanks for coming out on your Friday to hear me talk about this work we've been doing. I'm going to talk about this title about cognition across cultures, and I think culture is a really big loaded question. I'm still a bit frightened by this word culture because I've grown up in a very hardcore neuroscience. Culture is a tricky word, and so I'm going to be talking about cross cultures, mainly talking about how different nations compare today to each other, diving a little bit into culture at the end of the talk. And actually, while I'm giving this talk, I haven't done this in years, I'm going to hand around a prop. We'll start with it over here. John, you can have a look at this and figure out this prop. Pass it round. So if that just passes round the whole room and eventually, hopefully I get this priceless object back to my bag, that would be great. This prop going around the room will be explained in one of my last slides, why you're looking at it. So, yes, we're talking about cultures, and this is a cultural artifact from somewhere very far away, where people are fast asleep at the moment. But let me start today's talk, which is on, as the title says, I'm only going to talk about navigation across cultures with the face of a good friend of mine. This is Michael Hornberger. He was sitting in Cambridge in 2015, and I got an email from him one day saying, Hugo, would you be up for this? And he's had a mysterious email from somebody saying, we're not going to tell you who we are, but we've got unlimited money and we'd like to run a research project linked to Alzheimer's. And we just want one page. And so Michael said, should we do this? And we did. We wrote a one-page proposal to build a video game that would allow us to build a diagnostic tool for Alzheimer's, and we needed some money to make that happen. Turned out the funder was Deutsche Telekom. Their revenue per year was back then 68 billion euros. And so we were very fortunate. The money wasn't infinite. It wasn't even 68 billion, but they were able to siphon off 10 million euros to fund what I'll talk about. Most of that money went into advertising and branding, but a section of it substantial enough to employ a commercial games company that is to do what I'm going to talk about. So the proposition Michael Hornberg and I had was, it would be great if we could build a really exciting, valid test of navigation that tests people's navigation using a virtual environment that everybody can tap into, that can be accessible on a touchscreen device and downloaded by many thousands of people so that we can test lots of people. We want to test lots of people because we want to build up a database of norms. If somebody comes in with potential Alzheimer's, where exactly do they fall? And the aim was if we can get someone 10,000 people age 22, 10,000 people age 25, all the way up. But like those birth weight scales, if you're a parent, you obsess when your child is born, what weight do they come in at? We wanted to have this for navigation. And so we were very fortunate that Deutsche Telekom, that's their branding on the top left of this image, allowed us to hire for £500,000 a games company for a year to work on building a video game, which was branded and the name chosen was Sea Hero Quest. And there's some photographs of the images you see inside the game. I'll show you in a video next what it's like actually playing this video game. But the idea of the game presented by the company Glitchers, who built the game, was let's make an exciting adventure-based game where people control a little boat going through little ocean environments to find map fragments that their father, the boat driver, has lost from their Alzheimer's problems. And you piece these fragments together, you finally make your way to the end of the story, and you're going around photographing monsters, and you can share them through Twitter and other things. The games designers, when they first proposed this, wanted people to stab, kill, brutally murder all these meat creatures, and the funders weren't very keen on that, linking their brand, particularly Alzheimer's Research UK that partnered. The idea of slaughtering marine animals was not really on their agenda. So they moved it to photographing animals, and that worked. So people they chased through this world trying to find locations, to find map fragments. as I said, we had it in 17 different languages at launch. We've got it in Mandarin and other languages, over 20 languages now. And I'll remind you at the end that the app is completely free for anyone, doesn't matter who they are in the world. If they've got ethics, they can download, they can use the app, they can log into an online platform, get like 1,000 codes they want to send to people anywhere in the world. And those people can then play the game and you can access the data anonymously from Alzheimer's Research UK. But if you go online now and find the app, it'll come with loads of totally negative reviews. I downloaded it doesn't work. That's because we don't want anyone really now to play it without being part of research. As I'll say in a moment, we had 4 million people play this game because of a lot of the money went into branding. But the idea is not only to have it in lots of languages, but we would test different types of navigation. We'd also map people's video game experience because, moving a little boat around if you're in your 90s or, it's going to be very hard. But crucially, what I'll spend my time today is talking about demographic data collected. That allows us to tap into the word I had in the title, which is across cultures. One of the questions was, which country are you from? And some other questions. So I'll show you a video. This is in our first paper. This is a supplementary video in the first paper we published in 2018 when we only had 2 million people in the data set at that point. And this is work done by Antoine Coutreau. His name will keep popping up all throughout my slides. He's the person we hired as a postdoc to work on this project. He now runs a lab. He's had 2 large grants awarded to work on See Her Request. He has been the joy to collaborate with. And actually, one of the things I talk about this project is very much taking that action of taking up that email, saying yes, let's do this. With one colleague has led to some fantastic collaborations that I recommend in scientific life is really the lifeblood of science. So this black box here is a short video. If I get my mouse to behave. Let me see if I can get it. Here we are. Yeah, okay. Right, so this is a supplement. So what you're going to see here is what it's like to play level 8 in the game. You see a little map. I'll just see if I can pause that. Right, so you've seen that map. You've got to memorize it. The person there, you can view it for as long as you like. You see a little map. This is level 8 in the game. By the time you've reached level 8, you've worked your way through lots of basic environments to learn how do the controls of this boat work in a very simple environment. Once you've had a chance to look at that map, it tells you the places you need to get to, like markers on a map, and you get rid of the maps. You've got to use your memory, and off the boat goes. Here we go. So this is like what someone's seeing on their phone or on their iPad. And you can swipe to go faster. If you tap left or right of this boat, you control it. The whole time this person's playing this game, it's storing in their phone the GPS virtual coordinates, not where they are in the real world, but in the game. That's being stored and then transmitted to a server in Germany that we were then able to download. And this person's a very good navigator. This is Antoine driving this boat around. And the whole time it's logging that. Now, this is a very good navigator. And the key is that, here we go, so we picked up a mag. It's a game, so it's all very positive. You nailed it, fantastic. Loads of positive feedback. You gain stars. Stars mean prizes in the game. You could upgrade your boat, write your name on the boat. All the stuff you do if you have a large fund behind your experiment to actually make these things happen. So I'm now going to move to another video, which is one of the later levels in the game, but it's just going to illustrate what this data looks like. So you saw somebody going through the game. We extract out those coordinate information, that time series of their journey, and we can then plot. And we'll plot 101 people into this. So you can imagine if there's 4 million people plotted into this map all moving, it's just impossible to see anyone. It's just a big blob. But if I downsample from 4 million now so this is a different level to the one you saw being played. This one's more elaborate. But you'll see now, pardon me. I'll get this video to work. You see them appearing. So there's 101 people. There's one red dot, 100 other blue dots. And they're all setting off from the beginning here. They're all playing it independently. We're just taking all the data and merging into one movie. Again, you've got to imagine there's 4 million people like this. And you can see some people going very badly wrong. And there's some people very clear. There's a winner at the top. Now, the red dot actually turns out to be someone that gets lost every single day. They work in a building somewhere. They've never managed to learn that building. They cannot find their way. But you can see the diversity. This whole talk I'm going to talk about today is just taking each one of these trajectories and working out how long it is. So the good navigators are a very short distance and the bad navigators have got a very long distance. And we'll ask things like, do people taking a longer distance as they get older Do men travel shorter distances? Do some countries do better than others? All of those. You can see at this point it's very hard to know who's... If I jump forward in the movie, here we go, to near the end, it's a bit sad because the little red dot is still trying to find their way, right? But this highlights the value that what we were setting out to do is to look at Alzheimer's as a diagnostic, and we're looking at full commercial funding and building that now. But that's not what I'm going to talk about today. I'll mention Alzheimer's very briefly in one slide, but what I'm going to talk about is the cross-cultural questions. Okay, first thing we did, this is level 1 in the game. It's a river. You start at the bottom and you go in pretty much nearly a little shape, a snake, to the target. So even if you're bad at doing things, you can still do it. That's the target, the monster. So you've just got to drive this boat. As people get older, so I'm now plotting how long it takes you to do this task against age. And this is only probably 500,000 people. So we're talking in groups of numbers now. But this is the first plot I'll show you. So this is the data with the confidence intervals around it. So we've got less people as we go older in the data. But you can see they get kind of progressively, it's a little bit worse up until the kind of mid-40s, and then it starts to get slower. People are maybe less familiar with these games, they're not consistently playing them, and we get older. What we were surprised to see in our data was, wow, you get better and better after your 70s. People in their late 90s are fantastic. And this is very likely two things in our data. One, it's an incredible selection bias of people who are, if you have gone to an app store, downloaded an action video game and playing your way through it in your 90s, you may not be typical. You're particularly healthy, a bit like people who survive cancer. But also it's people who are just not really caring and putting in large numbers into the data. So with all the data I'll present, we cut out the data below 19 and we cut where we get this inflection point. I'll present the data, but the analysis I'll be talking about across countries and things, we've really honed into where's this coming from. So in this group over here, for example, I won't show you the slide, but there's an enormous number of left-handers, way more than you would predict. So we still have yet to write a full paper on really digging into who faked their data in this, but I think we tested something like 400% of the Vatican, the Pope and all the cardinals 4 times in the data. So we have ways of looking at the bias, but where we're confident is in this range from here. There's enough people in that data set to think, okay, this is even if there's noise, we're still capturing something. So here's the first real discovery we made, I think, with this data set was how far, what is the distance? So as I said, the good navigators go very low. This is a corrected distance score, so it can go below 0. But you'd expect people who are doing well, if we get worse with navigation, to be across the lifespan down here. And like we saw with that, I'd expect people to get worse up to their kind of 40s, and then where I am now, my mid-40s, getting a bit worse, and there's some incline. That's not what we saw. We didn't see something gentle. We saw, oh, you're getting worse between the age of 20 to 21, 21 to 22. There's, in this early data, at least, a nearly linear decline in navigation ability across the lifespan up to that bias inflection point where we're confident this is not valid data here. So we see this near linear, it's not quite linear, decline. You also see this, and this is all the data from the world collapsed together, an advantage for men, that men in red are doing better. And there's no gender-age interaction. Men are just consistently across the lifespan, across the world on average, doing better at this task. And we'll come to that difference as to what might be driving that in a moment. But this was one of the exciting figures we got out of this data, was to look around the world and say, well, great, we ask people where they are. Who's the best navigators in the world? I was curious as to who that might be. And raw data-wise, Sweden came out with the best navigators in the world. But they have a lot of young men in their data, so that biases it. When you correct for that, the Swedes get pipped by the Finns. The Finnish people, if you correct for all the comparisons and use very careful statistics, turn out to be the best navigators in the world. But they're not statistically really distinct. What we did find distinct using a k-means approach, so we take all the data. So if you do k-means over GDP, it's just smooth. Countries just vary. There's one big clump for GDP. That wasn't true for navigation. Turns out the best fitting model was 5 clumps of people. And sitting here in Cambridge in the UK, we're in the second tier. Turns out we're not in the top tier group. That top tier group is Australians and New Zealanders, North Americans, and the Scandinavian Nordic countries sort of clumped together. And a lot of these top two bits of the world, either side, do a lot of driving compared to others. So it seemed likely that driving might be one of the main factors. But that's not true in Scandinavia. And we'll come back to what it is in Scandinavia. And it's not what the Guardian newspaper said at the time, which is, it's the Viking blood. Okay, so we got this fascinating. The other thing we're looking at is why is India not doing so well? Why are these countries so good? What's going on? Why are the Netherlands also very good? And what we found is that one of those factors might be GDP. And indeed, this is the correlation we found in the first paper. It's quite a strikingly strong correlation between how much, and this is the rank. So down here are countries like Norway and Switzerland that have a large GDP. So they have a lot of, and that GDP allows them to provide a lot of healthcare, a lot of education, the country's capacity to do things for their citizens, to travel, all of those things are related. Sadly, on the other side of this, we have Egypt and India and Vietnam, places where there's less wealth, there's less opportunity for leaving the country, less education, and so on. And we'll come back to education as a question with GDP, because that's more of a mystery. But the raw performance, so we're ranking each country on this axis by how well they navigate, on this axis by how much money they generate, back when we did in 2018. So there's a link. So what that suggests, first of all, is that the country you live in, it's not just, oh great, there's a great culture here of cognition. It's that the wealth a country has, its capacity for education and healthcare and the things have an impact on a task we take for granted, navigating around. And it's also worth noting that GDP doesn't explain video game skill in our game. So the UK is the best in our data at playing video games. What I mean by that is how quickly they mastered the task, but we're definitely not the best navigators. So we win on something that's a bit more boring, I think. The Scandinavians could be glad of their cognitive skill. So this is something beyond just video games. So highlighting that this score here is not that, these people would just be good because it's a video game. It's not that. It's to do with the cognitive challenge in the video game. Right, okay, so I think a very interesting question for us was, why across the world is there a male advantage for this task? I mean, lots of small-scale studies run, but we found this consistent male advantage in the game data. But that gap is huge in Saudi Arabia and pretty much non-existent in Finland and in Norway and some other countries. So it's not that universally men just do better. Absolutely not. There's a big variation in it. And so what we're able to do was to get why that might be. We can rank all the countries in how big that gap is between those two lines. So Saudi Arabia comes out really, there's a big gap, and Finland is a very small gap. We rank them. So I'm going to show you on the y-axis next that ranking. Across the x-axis of the next graph, we're going to take the World Economic Forum's data on inequality. So Egypt and Saudi Arabia, there's a high inequality between men and women. In Finland and Norway, there's a very good quality of parity for men and women. Things like how many men and women are in parliament, what's the access to education for men and women. All those things get clumped into a metric that the World Economic Forum generate, and this is the gender gap index. And what we found was a significant correlation. So you can see there's some interesting outliers, like Malaysia and Korea are very bad on this, but the women are doing really good. Like Korea, the women live in an unequal society, but they're just as good as men at navigating. But across, on average, you can see Lebanon, Iran, Egypt, there's a big, big gap between the performance of men and women. And we come down to here, Norway and Finland, where, I think Finland still has a female prime minister. So this suggests, what does this suggest? It says at least part of the difference between men and women at navigation skill is cultural. There are factors that affect men and women in society. There may well be biological effects that mean men have some advantage. If it's there, it's small, because these countries show very little effect. But there's a big cultural effect. So if someone says, oh yeah, men are better at navigating, it's very likely to do with inequalities. And the UK is kind of somewhere, the United States is there, the United Kingdom's a bit higher. So that's one of the conclusions in this data. The value of taking large data is you can understand why some gender differences might emerge. I said earlier that it was a bit of a puzzle why the Scandinavian countries do so well in our test, because they don't drive very much. And an answer came from this. I don't know if anyone in the room has ever done orienteering as a sport. Any hands up? I've never done it, but yeah, Dan over there has done it. John, you done? Yeah? So two people in the room on either side have. So it seems quite a challenge. You're running around in a mud field space, or typically over some outdoor space with a map, and your task is to get to the different markers as quickly as you can. So you've got to run fast, and you've got to use your map reading skills. So it's a mental and physical challenge. But the fun thing is that 13 different countries take their best people and they throw them into an international challenge, and they win medals. Like how many of them? So what we were able to do is count how many medals each country's been able to accrue in that challenge, and then rank them in how good they are at Sea Hero Quest. And what we found was a significant correlation. I mean, this is a bit like those correlations between Nobel Prizes and chocolate consumption, where it's could well be spurious. But it's an ecologically valid check to say, well, countries like Sweden that win a lot of medals, yeah, they do very well in Sea Hero Quest. Austria doesn't win so many, and they're not quite so good at Sea Hero Quest. So just an interesting... But the bigger picture here is that these countries down in the bottom in blue train children at school to do this. So the whole population in Scandinavia learns how to navigate at school. It's not the Viking blood. Very little to do with Viking blood, I suspect. What you should be thinking in the audience at this point is, this is all great, you've created this fantastic tool, you're able to test it against things in the real world, like how well a country does at orienteering. Does it actually really test navigation? Because somebody might be good at video games, and it's ultimately a test on a phone like this. Is it really valid? So to get at that, we put people into Covent Garden. We gave them the test, but we also took them out into Covent Garden and made them navigate to different locations in Covent Garden under test conditions, and look to see whether if they did well in the video game, would they do well here? Or if they do badly in the video game, how well does the game predict the real world? And the answer was pretty good. So we had something like 26 participants, and there's some really bad participants there who are walking. You only need to go 500 meters, and they're walking nearly 2 kilometers around Covent Garden. That's what you would expect. So there's a good correlation, but we thought we'd repeat the same experiment, redo everything in French, and do it in the Montmartre area of Paris, and got nearly identical, if not slightly more significant correlation. So on face of it, this suggests that this game does have some ecological validity. If someone does badly in our video game, it likely predicts how well they will do in the real world. Not perfectly, not claiming that, but it does. We haven't published it yet, but up to the age of 70, the game holds pretty well in terms of predicting navigation skill. People in the late 80s, it doesn't. So you find that at that point, it's quite hard to play an action video game, and they might be fantastic real-world navigators. So what I opened with was saying the reason Michael and I got the funding was to try and build a tool that would help with Alzheimer's. So this slide, I'm just going to touch on what we did achieve so far was testing people using the ApoE4 gene. We're able to genetically screen people who are at high genetic risk or low genetic risk, and find that our Sea Hero Quest did a better job of discriminating people at high genetic risk from low genetic risk of Alzheimer's. And here's the map. We kind of found that people with this higher risk genetically of Alzheimer's were not only worse, but they would tend to hug the edge of the environment a bit more, which is something that Nikolai Assemacher in Germany had found in another study. A couple of months ago, we put out a new paper with the team in Oxford, who were working on the Mathematics Institute, where they took the same data and remodeled it with a lot more power from the large data, and took a whole lot of geometric features from the navigation data to look at. So what you're seeing in here is a set of different measures. Here's how long people take, what's the distance they're taking, the curvature of the path, the boundary huggingness of the data. So using this, we're able to dissect in and understand more about genetic risk of Alzheimer's. This paper is currently off under review, but just I'm going to leave that there and park it, that there's a whole journey in this story around Alzheimer's, but I'm not going to pick up on that today. I'm going to move to another question we asked that was about culture and experience, which we asked these questions inside our app because we wanted to know if we're building that worldwide map of how well people navigate. So we know that it declines with age. We know that on average men have an advantage. The next question was, is one of these environments to grow up in advantageous? So if you grow up in a city, it's full of bright lights. There's a lot of, like London has got a million ways, more than a million, it's very, very large n factorial problem navigating London streets. So growing up there would challenge you to navigate, but maybe you've got GPS and you can use Google a lot. In rural settings, you don't get GPS as much longer distances. So we're kind of curious as to, is there any advantage of growing up in a particular environment? Would it be better growing up in a rural setting or a city setting or a mix of these? So we simply asked people these questions. So we asked that, and we also, of course, got what country they come from. And so what I'm going to show you next is a graph, and on the y-axis is navigation performance. You'll see here we cut at the point of 70, where this range from 19 to 70 we believe is valid to look at. And this is with 4 million people's data downsampled to about 500,000 to really filter it so we can get all this data very carefully assessed. And now you're looking at navigation. The higher the score, the better. So this is going to decline. Not quite linearly, slightly curvilinear over the lifespan. And as you know, there's going to be a male advantage in the data. So we're going to split by men and women over the lifespan, but in grey and green, we're going to split between grey in cities and green rural. And there was an effect, but what shocked me was that it was quite a substantial effect. So this is in green are all the people that say they grew up outside of cities, and in grey are all the people that grew up inside cities split. And you can see it's not as big effect as gender on the data, but if we look here, a woman in her 70s who grew up outside a city is performing equivalent to a woman who grew up in a city in her 60s. So that's a 10-year health advantage cognitively, at least for navigation, of growing up outside cities. So quite a reasonable effect. And that's the worldwide average. We look at the data, just like gender differences, there are some countries where it's negligible. Romania, for example, you're slightly better off growing up in a city in Romania. But places like the US and Argentina, curiously, big effect, much bigger gap between rural and non-rural. And just to remind you, it's not where they live now, it's where did you grow up in your childhood? Was it in a city or was it outside? While we were thinking about this, a geographer, Jeff Boeing, had published a paper in network science, applied network science, where he was enjoying, as geographers do, trying to differentiate all the cities in the world under metrics. And he decided he could play with entropy as an idea. That if you measured all the orientations of streets in every city in the world, you could make a worldwide index of just how gritty all the cities are in the world. And so what you're seeing here is Prague at the top. You can see there's a lot of randomish streets. There's certain directions that are kind of more represented, north and south, east and west. But when it comes to Chicago, if anyone's been to Chicago, it's pretty damn gritty. There's very few streets that aren't off the axis. But if you plot that for all the different cities in the world, you get, I think, Chicago is one of the most gritty. Toronto's really gritty. But down in the bottom here, like Sao Paulo, I've never been there, but it's just chaos. The other chaos city I noticed was Rome. So people have been to Rome. I imagine many have been to Rome. There's no logical orientation in Rome. It just sprawls in each direction. What that then meant we could do is plot this graph, which is on the y-axis for a given country. All the dots you're going to see now are the countries. Let's take Romania. For Romania, how gritty are its cities? And we'll put that on this scale. On this axis, we're going to ask just how bad is it growing up inside cities compared to rural settings. So the further a country is over here, the worse impact it is growing up in cities. Whereas if you're all the way over here, it's like you're better off growing up inside a city. And what we found was a negative correlation. So up in the top left, I mentioned Romania. You're slightly better, not significantly, but you're slightly better off growing up in cities in Romania. But this whole group of countries on the right, the United States and Argentina, Canada, South Africa, have very gritty cities. So they're low here. They're like Chicago. Chicago scores at 2.5, so that's here. And the average Argentinian city, like Buenos Aires, is very, very much like Chicago. But they're also showing all these countries that the inhabitants there's a substantial effect size of growing up in cities is leading to worse performance in our video game. Our next thought was, our video game isn't just one test. It's not just one navigation test. In fact, we had 45 environments people navigated their way through. So you start with 4 million people. By the time you get to the end, you've lost a lot of people because of the way it's designed, just the natural nature attrition in data sets. But if we look at two of the levels we built, this is level 42, and it's very gritty like Chicago. Level 68, like Rome. So the question we asked was, okay, so we see that growing up in a gritty cities has a negative impact. Does it lead to worse effects here? And how do they do when it is gritty? And what we discovered in that previous graph was that some countries are specifically more gritty than others. So that if you apply k-means, there's a cluster here. So what we were able to do is distinguish between countries where they have gritty cities and countries like the UK and Ireland and Belgium and so on who don't have gritty cities. So we take these two populations and I now plot them. So in green are the countries with high street network entropy in their cities. This is like the UK. Cambridge would fit very well in that. In orange, we have countries where they're very gritty. What you see in this graph, so on the x-axis is just how disorganized are the game levels that are being tested on. And on the y-axis is how bad is it growing up in cities. So on average, across all the data, you can see it's worse on average growing up in a gritty city. But the people who grew up from these environments show the biggest effect. They're very sensitive to how gritty the environments are. The people who grew up, like from Cambridge, let's say, if you grew up in Cambridge, you're not very sensitive to the grittiness. The really striking thing was this, that it suggests that in gritty environments, people from, say, Chicago will do slightly better because we're going below the line here. So this is down below zero is people who do better. So there's a benefit of growing up in cities. This is a little bit complicated graph, but the upshot is if you're ever trying to find your way through Manhattan, pick someone from Buenos Aires to help you because they grew up in a gritty place and Manhattan's gritty. Whereas if you're going to go through the back streets of Dublin, pick someone from London, not Buenos Aires, because there's a shift. So we didn't conclude cities are bad for you. It's just they shape your... The paper we published in Nature has 1 billion extra things reviewers required us. We had 5 reviewers, each with vast requirements, like we redo the entire test again in a city-themed environment. Same effects. We also asked, where do you live now? Maybe you live in Manhattan now. And it turns out it doesn't matter. If you live in a really gritty city after you grow up, it doesn't change your navigation skill. Okay, I'm moving on now to getting into some more cultural effects, because so far I've talked about the grittiness. These aren't really things most people think about, the culture you live in. We found all these effects I've talked about so far, age, gender, and environment, they all have effects to play. But there was a number of papers suggesting handedness left-handers like Leonardo da Vinci, famously clever, might have some sort of cognitive advantage. So we, instead of taking did you grow up inside a city or outside a city as a metric, we said, are you left or right-handed? And we found this. The most boring graph I've ever generated in my career. So this is the effect size, and it's just nothing. It doesn't matter. I mean, this is big data showing, even with big data, vast samples, that's the error around the measurement, that across 41 countries, I think we published, it doesn't matter being left or right-handed. It really has no effect on cognitive ability, as measured by our game. What we did interestingly see, because we can obviously look not just at the spatial performance, just look at how countries vary and how much left-handers they have. We curiously saw more men reporting being left-handed. There seems to be like a cultural norm, and this is in the previous papers that reported. Women are less likely to say they're left-handed. But down here we have China, Vietnam, Hong Kong, Taiwan, all very not keen to be, not reporting lots of left-handers. And indeed we looked at the data split by education. So if you did more extended education around the world, it has no effect on whether you're going to say you're left or right-handed. There's not an increased proportion. But in China, India, Indonesia, Taiwan, and Hong Kong, there's a much bigger reduction in the people who to report being left-handed if they've had more extensive education. So these are cultural effects on reporting handedness. It's quite possible a lot of these people are left-handed, but they don't want to say because of the connotations in these cultures of being left-handed and being different. This is the worldwide map of handedness. So we were able to extract these kind of patterns, and of course, you'll notice in this and other maps the absence of Africa other than South Africa and Egypt. I'll come back to addressing that at the end. But you can see in the Far East there's a much less prevalence of left-handedness. Okay, I'll move on to a paper we've just pre-printed a few weeks ago. So this is not something that's been really discussed, and I'm showing these figures for the first time. So, my apologies if it's not as crisp and clear. But lots of studies have shown, going back many, many years, that with more education, cognitive performance goes up. This is a well-known, documented thing. Can we see it in our data around the world? And the answer is yes. We can see that for both men and women, there's an advantage that more education leads to better performance, and that gap gets bigger with age. So which is again repeating other studies, but you can see it. You can start to see the selection bias creeping in there for men. And we don't think this is a reliable uptick. But what you can do with this data as well is look at the effect, and so we can look at the gap between those two and see, as I say, that point here we have to treat more suspiciously because of other factors that to do with what's going into the data that I won't discuss today. I'm happy to talk over in the bar. This is a much more long story. But the upshot is that education doesn't matter for this difference so much until you reach your 30s. So we're starting to track that across the lifespan. But the other big thing you think was about GDP. Great. So if these countries with loads of GDP, maybe they've got great education, the education should really drive more performance. And no, not really. This is the effect size across the world. Vietnam, a lot of these bottom countries, there's no benefit of education on cognitive performance. We go to the end over here, Romania has the biggest effect, Germany, Belgium, Indonesia. And so overall, there's no correlation. We're a bit surprised. So this is how big, over here is how much you benefit from education. And on the y-axis is GDP, with Ireland at that point at the top. The Irish had a very cracking economy. So it doesn't appear that simply, you can't just take GDP, and so the GDP affects overall cognitive performance in our game for the nation, but it doesn't mean that it's not mediated through education, it appears. What we did find, what was quite nice in terms of correlation patterns, was that these levels I talked about earlier vary in how hard they are, and the harder those challenges we put people in the game, the more education mattered. So if it's really simple, like just driving a boat down a river, absolutely no benefit of doing a PhD. But if you've got to find 5 places in an elaborate environment and there's fog and the map is all damaged, then that's what the data suggests. It does help doing a PhD at that point. One of the fun things about this project is collaborators. So we worked on this, we talked about it, presented it, and Roger Cleavitt, was at the MRC unit, came forward and said, hey, maybe we can do some fun things with this. Because in the United Kingdom, back in 1972, there was a law passed, forced everyone to go to school longer. We still have that, but before 1972, you could leave school early. So that creates a natural experiment that says, okay, if the population are forced to do more of that education, and we've seen the previous plot, education benefits people, logically, you should see some step change. These people who are forced to go longer are better. And remarkably, that's what we found. So this is 2 regression lines fit in the data for across the group of participants we have before the reform and after the reform. And you can see with those regression lines going up that the wayfinding performance is better for the group after that point, but there is a disjoint. But more importantly, what we took was a change point analysis to see, or discontinuity analysis to see where's the strength. Yeah, you can take this particular approach of analysing the data across each of these time points. So this is the time point for people at this age who are born in that year. They would go on to be the first people affected by the education reform. And what we can see in the data is that is the point at which you get the biggest change in these patterns. If you refit that model many times with different points, that gap you're seeing here becomes very low, or is not affected. So we took this as evidence in our paper that policies matter. If you force people to go to school longer, you will get an up improvement. in something people wouldn't actually think about, in this case, navigating. I'm finally going to turn in terms of the worldwide patterns we see to sleep. And again, it's a warm room. You may just be getting to that point in the day. So I'll now start talking about sleep. We asked people how many hours sleep they got. We replicated lots of other studies where 7 hours is the average worldwide, plus or minus a bit. So not too surprising. We also found, like other studies, women like to sleep, in our case, 7.5 minutes longer worldwide. Not very meaningful, but highly significant. But this was the surprise to me. So what we're plotting here is the lifespan, up to our point we're confident, from 19 to 70. And on the y-axis, how much sleep do people report? We don't know if they sleep these actual hours. These are people just saying, yeah, I think I sleep 7 hours a night. Based on the large sample we're looking at and other studies, it seems likely that they're quite highly correlated. People do have some awareness of how they sleep. But what you can see here is that from your kind of 19, there's a significant decline in the amount of sleep people are reporting, to the point when you're kind of having children. And then there's a point maybe your children leave home and you're gaining your sleep back. This is more controversial, but what was amazing is if you do a change point analysis on the data, that curve is not smooth. It's not like we just there's a dip and back up again. Something happens at the age of 33 and 53. And for me, the neat thing is that if you split the data into men and women, the exact same points come out. If you split the data by developed countries versus developing countries, weird versus non-weird, exactly the same points come out. So it appears that universally there's something happening, at least in the reported data for our participants at these two ages. At current, we wrote a paper saying, we don't know why. Actually don't know why 33 and 53. Go on.
Did you look at who was the main caretaker?
No, we'd love to. Yeah, there's a million things we can't look at, but it motivates asking that question. And if you split by this, women are sleeping less, right? So it's like this is the... Actually, women are sleeping more. So it's not that if women were the main caretaker, they should be, or caregiver, they should be more affected. They're not. But yeah, I was really struck by this split.
Hugo.
Yeah.
There's an interesting coincidence. Another group of people who does super large N studies are economists. And one thing that economists like to look at is happiness, believe it or not. So it's a simple happiness index.
Yeah.
And so they have worldwide happiness as a function of age. And also in a more nuanced way than happiness is specific types of emotions. And you see pretty much exactly that same curve, and it deflects at the same point.
Yeah.
At age 50, and it starts to go up again.
Yeah.
So basically,
You're getting
you get more and more miserable.
Yeah. You're getting less sleep.
And then things start to go good.
Yeah. So everyone yeah. Absolutely. And it is universal for men and women. These different trajectories, but they change at the same point. So it could well, this fits. This is very, very, very true, Mike. It's very good. It's really fun looking at this data for that sort of, you can bring in happiness. Yeah, I'll bring in masculinity in a moment. We didn't look at it. I think we had a peek at happiness, but it's not got the same granularity. I'll have to look. The paper definitely picked up on, yeah.
It could also be like employment demands, because I'm guessing people between like 30 and 53 are like really trying to get their career sorted so they can retire later.
And unless there are clarification questions, could we keep them?
Yeah. Because I think I'll run to the hour. But yeah, if we keep chatting, let's raise those. So, the next question for me: who sleeps the most and least in the world? We've got 67 countries. I don't know if you have your internal. Just for a moment, think which country you think's really sleepy, who's really not sleepy. It turned out Albanians are off the charts reporting being sleepy, and people from the Philippines report being the least sleepy. I'll remind you again, this is just self-reported sleep, so we don't actually know whether they rank. This is color-coded by, I think it's Ronan Shenkar's cultural clusters, and you can see it is culturally clustered. There's more of the dark blue countries down the bottom and more of the green at the top. Curiously, Israel and Iran are like flipped. They don't fit where they should be. I think people in Israel sleep. Where are they? Let's have a look. There's somewhere. Here we are. So Israel's in the top cluster, but Israelis are not reporting sleeping as much as they should be culturally, whereas people in Iran are the blue line, are right at the top. They're sleeping much longer than they should. Curious. We don't know why. But what we can see are these clear cultural clusters. So Far Eastern countries tend to report not sleeping very much, and Eastern Europeans report sleeping much more. And if I plot this geographically, you can see it. So you can zoom in on Europe, and you can actually see an East-West in Europe divide between it's culturally acceptable to sleep more, to report sleeping more, or less culturally acceptable. Like in Italy, it's not as acceptable. You can look at this map and see that some of the warmer colours for longer sleep tend to be up north. And we were able to look at the distance from the equator. So what you're seeing is duration of sleep, X, Y, and then how far away from the equator are countries. And it's correlated. So countries who are further north sleep less. Sorry, closer to the equator, you're sleeping less. And of course, the big criticism is remarkable we got this, because a real confound in this question is, when did you ask the people? Was it you sleeping in winter or summer? Because in Finland, it matters a lot. So I think this correlation would be even more significant if we're able to account for what time of year we ask people. But I'm now going to just does it matter for cognition, this question? Does the sleep actually matter for performance? And so what I'm going to plot now is how many hours sleep are people getting and how much is the performance going up or down. So high on this chart is good performance, low on this chart is bad performance in our navigation task. So if sleep matters, maybe if you're getting less sleep, you see a line going down. 10 hours is great, 5 hours is terrible. You'll expect to see a line just going down. And I'm going to take this first graph is that first period when we're young and getting enough sleep. And it doesn't matter. Not getting much sleep or getting a lot doesn't really affect your performance very much. I'm plotting both in orange the wayfinding task, but in green are following the boat round a river to a target. Neither are affected by sleep. Similar-ish in middle life, but up to 53. There's not a big effect of sleep on either of these tasks. But when we reach later in life, you can see the easy task isn't that affected by sleep in green. But the wayfinding, people who report getting 7 hours of sleep are doing better on this task than people who are saying they're getting less hours, or in fact in this large sample, more hours of sleep. We've since followed this up with about 1,000 US younger participants and found that we see this pattern here. It's not so evident there, but you can replicate that. But this larger pattern is less clear. But in the large data, having lots of hours of sleep doesn't tend to be associated with good performance. And it may be that getting 10 hours of sleep is suggesting someone's having problems, that they need all those extra hours. So that relates to that. So the upshot is that later in life, sleep matters, but less so when you're young. Last slides, I've got 10 more minutes before the hour is up, is we also ask people in our questionnaire, how good do you think you are at navigating? So if people are really good at this, you should have people in Finland saying they're fantastic, and people who are in, say, I won't mention the countries' names, but countries on that list who didn't do with a low GDP should say, we're okay. We're okay at navigating. We're not great. So what we can then map out, as you can see from this, are the countries that do really underestimate how good they are and countries that think they're great when they're not. So again, in your head, you can try and have a think about which countries do you think might overinflate their population level and which countries might be self-effacing and not want to say they're good. So have a think about that. All right, I'm going to reveal. So the whole Russia, China, Far East, they're very self-effacing. They don't want to say they're good at this. Finland's the same. Finland's the best in the world. We don't think we're very good at navigating. But if you zoom in on Central Europe, you can see Germany and Austria stand out as thinking they're really, really good at navigating. And the interesting is they are, right? Germans and Austrians are good navigators. They're in the top quarter of the world's navigators. It's just based on where they rank. They think they're out at the top when in fact they're not quite there. Whereas Finland and other countries are like, yeah, you should come up. So we had a bit of a challenge. So GDP doesn't explain this. Lots of factors don't explain this. We tried to work out what might mediate this factor. And I don't think we got a great handle on it. And that relates to the fact there's not endless evidence. As Mike just said, you can get a happiness. I don't think we didn't consider happiness, but what we did consider was a study by Hofstede and colleagues that measured things about a range of factors. One of them was masculinity. So this is questions that are things like, if you're flying on an airplane, would you rather have a female or a male pilot? Or does it matter to you? So what you see in Scandinavian countries is this like aversion to questions like that. Like, this is an equal society, that's outrageous. Whereas some countries, as we'll see, Slovakia in our data is the highest affirmation of, yes, I'd rather have a male pilot fly me somewhere. So each country varies. And what we found was this overestimation is correlated with that masculinity metric. See, Austria and Germany are at the top there, and they have a slightly more than average affirmation of masculinity. Whereas down on the left, the Netherlands, Denmark, Sweden, Norway, they're at the other edge of the graph saying we want an equal society when asked about masculinity questions. So it's a significant correlation, but it's weak. So it suggests there's some weak effect. What we argued in our paper in Scientific Reports was there's a weak effect of something cultural about this masculinity feeding into stereotypes about navigation being a male-oriented activity. Because we can see in the global data there is an evident effect of gender driven by that gender gap index. So this is where we're starting to get more towards cultural effects of things like appreciation of masculinity in culture potentially affecting how people self-rate. And not just how they self-rate, but their overestimation based on actual tested performance. So I'm going to go back to that big graph and end my talk now at 5 minutes. We open it questions and highlight. We've done all this fantastic. I've really enjoyed talking to you about all these graphs and walking through world data and world economic data. But my goodness, there's a lot of grey gaps in that chart. The whole of Africa, except for South Africa, is missing. There's this is not an error in the projector. It's Hawaii all the way over here. They are part of the States, but do we really test them? There's a large array of countries scattered over the oceans there. You can't see, they're tiny, but they exist. So what I'm going to move on to now is just to highlight at the end of my talk about the importance that this work has done in highlighting to us that we must get out and start asking questions of how do people perform, particularly when we can see economic differences affecting cognition. I'm pleased to say we've now collected data from about 200 people in rural Rwanda through a collaboration with a team in Belgium. So they've gone out into the field, tested people on Sea Hero Quest. We've tested people now in the outback of Western Australia from traditional communities. We're mapping that. So it's not just let's tell people how Rwandans do, but also an acknowledgement that people differ. So this is a paper we wrote earlier this year in Trends in Cognitive Sciences on what can traditional cultures tell us about navigation? Because what I've just talked to you about today is mostly non-traditional cultures. But there's a wealth of information studied mainly by anthropologists and ethnologists who study people out in the open ocean or in river basins in the Siberian North, and as some of the work we've done also in London. I'll come on to that in London, with London taxi drivers. Now, you've been panning around, and hopefully it's not gone missing out the door, some sticks tied together with little shells on it. It's sitting back at the front, it made it back. And so, has anyone guessed what that set of sticks is? Yeah.
I was guessing it's some kind of like a map or like a quest map.
Great. I mean, is anyone getting any? Yeah, you're right, it is a map. Does anyone get any other yet?
I would say they're islands, maybe?
Yep.
And then, I don't know if that's a boat or something.
Great. No? Okay, that's really great. I was hoping nobody would know. So I'm really happy today. If you'd all gone, yes, I know, it's really tediously obvious. So those little islands on there, let me lift it up. Thanks. So this to me looks a bit like, it's like lots of children's lollipop sticks taken apart. It's not. It's a set of roots from a tree from a tropical atoll that have been cut, very carefully prepared from a particular tree, with some coconut fibres. Each one of these little cowrie shells has been individually placed on with glue. And in the top, I get the right way up. Get the right way up. Yep, where is it? It's this way, yeah. Right, because it is, no, it's that way. They're all different orients, so finally got it right. That's the kind of orientation on the world's surface. This is what's known as a stick chart that's been made by And this has been handmade by a team in the Marshall Islands. For 1,000 years, people have been creating these stick charts. They're not a Euclidean map of space, but a topological map. It's partly a Euclidean. This top atoll, if anyone was really focusing in on it, would have noticed the words Bikini Atoll. If anyone knows their history well, they'll know, yeah, Mike's nodding, there was a hell of a big bomb landed on Bikini Atoll, blew the shit out of that atoll, and it's still got a bunker over it, keeping the radioactivity in there. So the Marshall Islands are this part of the story about us. We've been testing global navigation, but actually we need to go there. And I started my talk with, and sorry, just to explain what this is before I go on. These are the islands, and these are the interconnections between them, but these other bits that are running through it are the swell patterns that run through the ocean over, and the distance from here to here is something like 200 or 100 kilometers, very long. I forget the full distances, but it's somewhere like the size of France. It's huge between these tiny atolls. These are the swell patterns that the master navigators of the Marshall Islands would learn, and they'd hand these down and use these to learn how do the swells, because there's a main swell that hits all these islands, and these bits here are the reflections of the waves. So what these islanders do is sit on an ocean view like that, and they'll travel 100 kilometers with no GPS, just feeling the waves and the reflected waves they can feel. And there's been extensive research to try and monitor these waves. And so I started with the email from Michael about this project. After that, I got an email from somebody in the Marshall Islands who said, would you like to come out and study this? And that's why I have this in my hand, because I flew there over summer, went to the one tourist office in the entire country and purchased this. And we're really fascinated to try and understand these people who build these stick charts. And it's not just them, but the whole, there's tribes in a vast number of different places around the world. The Hadza people are really fascinating down here, the Zulu, the whole range. So we've mapped out in this review, if you're interested, where are all these people? Who's been studying them? What do we know from them? Because I had no idea until we took the time to review it. And Pablo Fernandez Velasco is the lead author, and he's a philosopher, cultural anthropologist, so he had to dive into this. The main upshot of our article is to say that in traditional communities, it's often embedded in religion. So people navigate using the landscape as part of their culture. That's really, and I think we need to, part of the upshot of this is we need to return to some of that, because we're losing our sense of who we are and our appreciation for the natural world. This is my last two slides. This is Alison Kellen, who we went to visit, standing by the boats he's built. He is the last of a long line of thousands of years of navigators. And when I say navigator there, I mean approved by the chiefs, and you occupy a particular status in society. And he may, with him, die the last of the ability to use these maps. So we're hoping we can change that through research funding. This is Graham Greenglass, one of 25,000 London taxi drivers who we're still puzzled why in 2023 are still managing to get away without using GPS and Google Maps. So he uses his brain, like all the other cab drivers, to navigate. And I'll end on the last graph to say, it's great testing these guys. You ask them, how well do you navigate and do things? But actually, we want to get into the mechanism. How are they using their brain to navigate? And one way to do that with the taxi drivers is to get them to do the thing they do so well, which is, if you've ever got in a London taxi, you can ask them to tell you what's every street between where you are to anywhere else, because that's the exam they have to undergo. So this is somebody doing their exam. It's very hard to see. There's tiny little grey streets here. They have to tell you every street between Royal Oak Tube to Revolution and Clapham High Street. And if they make a single error, they're told, sorry, you're not going to get your license to operate. What we were interested in is sometimes they pause and really think about it, and other times it's like, it's 500 milliseconds to call out the next one. And the important thing is that we've been able to work with Daniel McNamee, who was here in Cambridge, to think about things like successor representations and entropy and the decision structure of how those streets are structured as to why they're making a longer time to make decisions in parts of the environment. So I'm not going to run into the full detail of this. It's just to highlight where this field needs to go next, is to exploit things about the environment, tap into decisions they're making, and understand what are the ways in which we can work out what is driving successful navigation. So, yeah, I'm just going to conclude by saying I hope I've told you the promise that games like we've shown can help. Navigation varies with a lot of factors like sleep, gender, education, and so on. Self-estimated ability seems to be partly associated with cultural norms, and future research needs to explore broader groups, not just the people we've tested, and these levels of experience. The master navigators of the Marshall Islands, what can they teach us about navigation? And hopefully we can preserve some of that culture that's sadly being eroded with modern technology and climate change. On that note, I'll just thank, and we've got the platform. On that note, I'll just thank the funders and the key people I've mentioned, Michael, Antoine, and others who've made a big difference. Thank you very much.
Thank you very much, Hugo, for a fascinating talk. We'll now take half hour for questions. People who need to leave, we can do this now. Just wanted to mention that Hugo is free to join some of us for lunch at 1:45. If you're interested in joining, there's a last remaining place or two. Please come and talk to us after the talk. He also has a little bit of time at 5 to go for drinks. If you're available at 5, between 5 and 6, come and join us in a new location, the Cambridge Lab, which is on 90 Regent Street, very close to here because the All Bar 1 is shut. So anybody who's attended the talk will get a free drink. So come and chat with us at 5 o'clock. And now for questions, are you happy?
Oh, of course, very happy, yeah.
Yeah, Anastasia, do you want to start?
Well, yeah, my question was basically maybe the 32 to 52 age range is just more stressed out because they have more like career demands.
Yeah.
They're sleeping less.
Yeah, absolutely. It does suggest we need to collect more data like that. So Mike was saying about happiness has been collected, but what is going on in terms of your demands? We couldn't find. We looked. Would have made the paper a higher impact if we were able to say, here's the mapping of how much parenting demand or stress you experience in your life that would fine-grain detail. But yeah, I think you're right. It's not just parenting. It's work demands. Yeah.
In all the findings that you mentioned were different between males and females. Are you asking about gender identity or looking at sex and needs?
So we just had male, female, other. So we didn't, and we got very few other responses to look at. So we haven't looked at that, but it's a really interesting question to look at, and again to look at across cultures. So certain cultures have particular norms going back a long time about, certain groups. I think there's a particular country in South America where it's expected that certain boys will grow up to be girls, and it's very accepted. And so there'll be also cultural expectations about what they should and shouldn't do. And so I think that's a really interesting question. So the answer is no, we didn't get to that, but it's a good question. Yeah.
Thank you for sort of this fascinating work, and especially this commitment to looking at culture as well. I'm formally trained as a cultural anthropologist.
Oh, wow.
Psychologist, but I do have a slight discomfort with how cultures as a word is being used, because it does seem that all of the studies, it's more geographical location and borders, and this kind of conflation between culture, nationality, ethnicity, and even religion is a bit.
Yeah.
I don't know. I have a
No.
worry about that. And so, how do you navigate between that? Because I've seen just culture being thrown, and even culture, especially. I know you're collaborating with Fernando Velasco, who's a cognitive anthropologist. Culture's not a bounded entity.
No.
It's not, and it just seems quite homogenized and. An assumption that's underpinning a lot of this. About how do you?
Yeah. I think your I think your criticism is absolutely spot on. So I'm sort of standing here giving a talk and saying these things and arguing it, and I think as I tried to claim at the beginning, I said as a neuroscientist coming into it, I think it's a concern I have, and I think you've very kindly responded saying, yeah, this isn't as good as it. This could be better. This could be better framed, and I think that's our responsibility to do that. And it's really in that previous paper here where we shifted towards that, thinking about it more deeply. So drawing on that. Part of that paper, in my view, is a chance to complain about some of the, to lay bare and say, look, we've used See Her Request. We can take it to countries, but taking a boat round somewhere, is that understood in the same way by different people? So yeah, I completely accept your comment. Yeah, it would be great if you have time to chat, because it'd be nice to know a bit more nuance that we don't have time to talk about. So yeah, for anyone in the audience, I think, yeah, I completely agree. There's a challenge here. And when I put the culture in the title, it's like, yeah, it's difficult. Yeah. I think, John, you're next. Yeah.
At some points, you were arguing that a difference in performance varied with, say, age.
Mm-hmm.
So I think city dwelling versus non-city dwelling,
Mm-hmm.
and so on. So the effect of age was different. That looked like the fallacy of reification of the ordinate, where you're assuming that the ordinate is measuring something linearly, whereas clearly you could get completely different results by adjusting your test. So the steps in the test were bigger or smaller in different parts of the range.
That's true. That's exactly a fair criticism. And a lot of what I've shown here as well, more broadly, we built a test of navigation. If you were to take another test that's, say, more say self-motion based, so you kind of going into a forest and you're trying to think, how far have we come? Where did we enter the forest from? Which is a topical path integration. I might be presenting very different results here. So it's another pinch of salt in all of this to say, unfortunately, we won't be able to measure everything in terms of this topic of navigation. But your point about there's different ways you could have set up the difficulty in the task and how that might have affected performance, and that it's true. I think we've just with this data tried to look over these different, tried to just take a simple linear model approach or a mixed model approach to modeling it, and we could do more. I think our hands up is there's lots more we could do with this data, really. But this seemed like the most parsimonious approach to start with, at least. That makes sense? And yeah. We could probably chat over beer if it's helpful, but I mean, we did look at things like, we did have a number of other tests in there. So we see very similar patterns, for example, that as I mentioned, there are other tests in there show similar patterns, but they're a little bit different. They're not exactly all matched. But so I think the data is going to hold. It's just there will be differences in it. Like the degree to which it matches GDP will vary with the extent to which you're tapping into executive functions or not. Does that make sense?
Yes.
Maybe I'm not answering your question fully.
Well, do you know this term fallacy of reification? Making a thing of what you've got on your ordinate. The classical example is probability of recall against time for amnesics and normals, and the slope is the same. And therefore it's concluded that the memory decay is at the same rate. And of course it's a fallacy because the amnesics are measured at a different point on the ordinate from the norms. And you're not actually measuring the decay of the memory trace. Some items in your set are easier to recall than others.
Yes, yeah.
And so I don't think you can ever conclude anything from differences on the ordinate where the differences are taken from different parts of the ordinate.
And to give an example here, do you mean so different countries? When you try to go and compare a different country, you having different...
Sometimes you were taking not the actual decline in performance, but the difference in performance.
You mean like so between men and women? Taking that and saying these two slopes, and we're going to take the difference, so we're going to...
Sometimes it was parallel, sometimes it diverged. But because you don't know what your ordinate represents...
You could end up with a misleading result.
You really can't conclude anything. So at one point you asked whether there was an interaction. You really can't, because the ordinate is quite arbitrary. You could change it entirely by changing your test. Just, having more difficult items, more densely concentrated.
Yeah. So the conclusion to a way to tackle that would be to have multiple tests and look at the to see whether this is affecting the. You say ultimately you can never really know, but I think you can look at my view. But you can look at that data and make some inferences from it. But your point is you have to be a bit careful about the full extent of the inference you're taking from that data. I wouldn't go as far. I mean, it sounds like you're saying you can't draw an inference from it. I would kick back against that. That seems a bit too strong to say. But I think the idea that if you're varying this test and trying to account for that when you're comparing between, say, men and women, that is a valid consideration, without question, that it would be useful to look at it. And we didn't do when we first presented the study, do that. So giving a talk like this is great to think, okay, let's go back and maybe look at variation in difficulty. Does that metric hold up? Because we did with the education, maybe process that further. Does that make sense? Okay. Yeah. Paul? Is it?
So when you showed the plot very early on showing that the performance declined very steadily starting at Payne's frenzy, it immediately made me think of similar data on visual working memory performance. I'm sure there are many other cognitive domains where you see similar things. So my question is, to what extent can you decompose the different elements of this task? There's clearly a very strong working memory component. There is in navigation in general, but specifically in
we
task,
really loaded it.
You get to look at this map briefly and now you have to remember it, right?
Yeah, no, we can't. There's a limit to what we can do. So with the test, and that's one of the things to go back to say when we did the project, a benefit was getting all this data, having that income. A challenge was the games company building that game were not going to release a boring test. So we would constantly come to, can we vary these things and do exciting bits and vary these? And they would say, no, that's never going to happen. It's too boring. We eventually forced in a bonus level where people play a radial maze. So we took a particular paradigm that's been well worked up in a lab, put that into the game. We had a paper all about validating that and showing how that works. That looks at working memory explicitly. We get very similar patterns. There's a decline across the lifespan with that data as well. But your question would, can we tease apart more of these different factors? To a degree, we haven't done enough. We've been focusing on a lot of these other things, but we haven't really done enough, I think, on that topic. And it's a bit difficult. It's not trivial to do it. It's partly why. So the levels vary in a lot of factors, but how they relate to working memory or other features is not a simple mapping, if that makes sense. But I'd like to do more, if that makes sense. Yeah. I'm not sure who had the next one. I think Debbie had a hand. Yeah, sorry, Deborah, yeah.
Just a similar kind of question to John and Paul. I think it's really fascinating and admirable how you mapped research and gamify it in a way that you could get so much data. So I'm not coming from a critical place, but I think it would be really maybe interesting and useful to understand the details of how you controlled for video gaming, mobile technology familiarity. I'm just thinking about my mum. She can probably learn, and she would be interested in how you move the boat. So maybe it would take her time, and you can control for that. But she gets lost with Google Maps all the time. She doesn't understand how to use the street and the little dot. So could you tell us a little bit about how you control?
Yeah, so that's a good point. If I go right back to my early slide, it'll let me. What I should have said early on is when we were analysing the data, no, maybe not. Let's see if it'll let me do it. Yeah, that first plot that we were just discussing. Whoop, there we go. This one. Hopefully this will just be nice to me. This plot here gives you that score of how well, so you were saying your mum, if she's picking up this bow, my mother did this in her late 60s when we were first developing this, and crashed into the side and was like, oh, this is really frustrating. And I was very happy to design this experiment as a boat in the ocean, because when I get in a boat, I'm rubbish. It feels naturally annoying. Had we simulated a little person running around, it'd be like, this should be obvious, but I keep hitting walls, which a lot of games do. So the boat on the water, I think, was very helpful. What we were doing, to answer your question, was to take that metric of how well somebody could do level 1 and factor that into the analysis, so that when we're looking at those scores in the next graph, that's factored into this. Oh, gone the wrong way. Yeah, so this is distance here, but it's scaled by that first level performance. And when we've done further follow-up with groups, we take that into account, how well they are at learning the controls. And certainly my mother was very slow, frustrated by it, but did a lot better than my 6-year-old son, who mastered the controls immediately. At 6, he knew what he was supposed to do in a video game, but didn't have the kind of understanding of the working memory that Paul was just talking about. How do I get to the first marker, then the next one? So that's how we've controlled for that to some extent in the analysis. So we know, for example, when I look at GDP, this isn't driven by that, what you raised.
Familiarity with video games, is there any other control of simply using a mobile device for navigation?
No, because we would love to have asked these things, and we're very limited in what we could ask. But I think what you would find is that probably will correlate with how well they learn level 1.
Right.
It's like, if you've got great visual motor skills, you'll learn level 1 fast. If you've got great experience with video games, that'll also help you, both of these factors. So we wondered about asking, how much video games do you play? But actually that metric we saw is probably so correlated and more finely related to it. But again, there's limitations in what you can do in pushing out an experiment like this, yeah. I'm not sure who came up next. There's 5 questions. Maybe Mike, yeah.
So can you go back to your aging?
Yep. Behaves, yeah. Oh, yeah.
Yeah, that one. So, everybody looks at that and they kind of nod their head and says, yep, as you get older, you get worse, right? It's really easy and intuitive conclusion to make. It's worth pointing out, however, that that is not an entirely uncontroversial claim. In the aging literature, there's a bit of a controversy between longitudinal designs versus cross-sectional designs. Lars Nyberg came to the CBU a decade ago and had some really elegant, super high-powered comparisons of the two. And the nice, easy conclusion, similar to this, that you get from a longitudinal design, often completely does not bear out. I'm sorry, from a cross-sectional design, often does not at all bear out if you use a longitudinal design. What you tend to get is basically flat until you're about 70.
Fascinating.
And then things get noticeably worse. So this, hard as it may be to believe, this could be partially or even largely cohort effects, which you're willing to hypothesize with respect to the 70 to 80-year-olds and beyond.
Yeah.
But actually, it's
before that as well.
likely to suddenly appear at that age, but would influence the entire curve.
You're absolutely right. Yeah. When I'm saying, I think it's that when I deliver and say, this is what we see, there's an implicit build into that. But like you said, most people nod their head and think, oh, yeah. But it is both age confounded with the cohort effect. Yeah. These people, at a certain point, are less likely to have grown up with digital technology. But if you did longitudinal, we might find... For sure. There's no question that. I think what's intrigued me, going back to the last photograph I shared of these 2 men, is the taxi drivers. We found they're getting faster and faster into their 70s. We start testing them in their kind of mid-50s at solving this task. They're getting faster with no decrement in ability, which really surprised me. But it's more like a crystalline knowledge of, like, they build up these street networks in their head and they're delivering it faster with age. So I also, this graph for navigation is our Sea Hero Quest story. If we've been showing it for, like, knowledge of street networks you've learned over your lifetime, it would be flat at a cohort level as well, I think. So it does matter, taking it, whether it's cross-sectional or longitudinal, and who and what task you're looking at. So all these factors play in. All I'm able to do here is present what we got from this large-scale data, if that makes sense. That's a good point. There's a lot of other questions, maybe I'll go with you,
So it kind of links a little bit to the previous question. So I was wondering, for example, when you look at the GDP, you look at the GDP from the year that you're
That's
analyzing, right? So because you showed before how, for example, extended education in youth can then have longer lasting effects, right?
Yeah.
Did you also do this with any of the other measures?
That's a good
look
point.
at the average GDP when someone was growing up, for example. I was thinking about this.
That's a great question.
With Germany, because you take Germany as a whole, but if you have older generations in Germany, some of them would have grown up in the East, which had very different.
That's an excellent suggestion. That paper is still in production, so we can do that. We haven't done that. That's a great idea. It seems obvious as well. It's like, why didn't we do that? But great. Sorry, you've been waiting a while. Thank you.
So 2 questions. One is on video games and one is on heritability. I'll start with the second. Because biological and non-biological factors. Because I'm very curious. It's almost like I'm imagining that education and sort of non-biological factors, let's say, just to avoid culture, non-biological factors will have strong effects, as well shown. But at some point, it sort of levels off, and then maybe it becomes more heritable. So the parents' abilities is what predicts ability. I'm sort of imagining that. I have no idea. Can you just riff on that point?
Yeah.
And the second one is on video games in general. Obviously, you used to video game, and I'm very excited for the future of this. I know that there are papers coming out kind of really supporting going for video games, but it's very hard to justify in my mind. You spent half a million, was it?
Yeah.
That's a lot of money.
It's a lot of money, I agree.
Yeah, and I believe, just kind of, I think I got the gist of the game. You can get a 2D version of that in like a web-based browser, like a couple of hours, right? Super easy. So how do you justify this cost?
That's a great question. Exactly.
Well,
first of all, I don't. It's a great. I'll do that first and the second one. It's a really interesting question. How the hell do you justify $500,000 for what? It's right for a research study, and the answer is I don't justify it. It's the economy. Like how much does it cost to hire in a professional games company? And if you say we want to make a short movie about Cambridge, we're going to get in Steven Spielberg to help shoot it. How much is it going to cost? And it's like that's what drove that. The project was set up to go, let's work with a professional company. They are expensive because the standard rate, the video games economy in the UK is like Hollywood. It's very high. So that's why it was just to switch from doing it as a kind of me as an experimenter to a professional inflates the cost through the roof. We're not well paid as scientists as well.
Sure, but do you feel like there was an improvement in quality?
Yeah, that's a really good question. I felt like we are gaining some things. What we gained out of that, I think, was the engagement. There's no way we would have had 4 million people do it without that. That's what we gained, I think. If you try and make a basic one, it's harder to engage people and get them to do it. I think we were able to look at a lot of richness in the data, which we wouldn't have gained. There's a lot of work on functionality to make it. So you're thinking, if you were in your 60s, this would be really hard. But we designed it with that in mind, did a lot of testing with it. So that's the justification. If I was writing a grant to a funder and said, could we like to use taxpayers' money? Yeah, we're going to use $500 million for this games. I wouldn't fund that grant. That's crazy. Because I don't think, we've had the opportunity here to test a lot of people. That's the value of it. But in terms of the economy of a non-private tax-funded, no. What I didn't say was chatting over coffee that part of that money we were given, they took, after a bit of discussion, $30,000, and they gave it to one guy for 5 minutes of his time to just talk about the game. His rate of work is $30,000, and this guy was PewDiePie, who's still like one of the top YouTubers. So what he did, so it's crazy, and I was thinking, imagine writing to the MRC, dear MRC, we've got a test, we'd like to reach out. We just need this one guy. Yeah, his salary rate per hour is whatever that would be. But on the other side of that, he got 5 million people to watch the advert in one day. Then the app became the most downloaded app in the world for a day. And that meant a lot of people stumbled on the app. They just happened to go on and find it. And we're able to look at South Africa, United Emirates, places like that. There's no way we'd have reached without that 30,000 spend. And so the other side of all this is why did they spend 30,000? Why did they spend it on? Why are they doing all that? It is their logo. If I go back, they just want that logo. There. T-Mobile sponsored this game. It's very clever. They've reached out and engaged with excitement and an exciting thing 4 million people. That's a good spend for your however many million you spend. 10 million is peanuts for global advertising. Sadly, that's what the world gets spent on. But your other question about heritability, the short answer is that no, we haven't looked at that. I'd love to run a twin study, right? But we haven't. I tried to speak to the people who are in charge. Haven't made it through yet. So if anybody knows someone that can get into a twin study, that would be great. But we haven't done that. We have tested 1,000 people through the Understanding Society birth cohort. So we're waiting to look at that data. But that's the nearest. That won't get at that problem, but it will tell us more about upbringing and aspirations in early life and if these relate to the data. There's some other questions? Or yeah.
I was just wondering, So the original idea was more connected to Alzheimer's
Mhm.
research,
Mhm.
and then I'm thinking more in terms of like natural navigation. So with that's ecologically compatible in natural worlds, that's usually not using maps.
Yeah.
So how did you kind of deal with that?
Yeah.
Like using landmarks and everything.
Do you mean that transition I talk at the end about going into the importance of traditional cultures and how to get at those, or?
No, kind of like how did you explain that you use this map finding as a measure for navigation? That's not the same as like how you would actually navigate like in building.
Ah, right. So if I understand you right, that a lot of people don't do this task.
No.
And I think that's why we're not getting a super strong correlation between self-rated navigation and how they do in the game. Because some people think, yeah, I'm quite good at navigating. I get around with Google Maps, okay. And then when you're confronted by an actual challenging task like this, it's much harder. So there's not an attempt to really do that. The latest work we're interested in, looking at traditional cultures and more broadly, then we do need to start digging into more and saying this test has a certain set of features to it and limitations, but it has advantages. And so there's pros and cons, but we need to think more broadly. Challenge I'm going to end on is that the guy, the master navigator. I should also say I showed a taxi driver and a master navigator, both older men, both bald. Actually, the nice thing is there's a lot of female taxi drivers now, and there's a training in the Micronesia, Federated States of Micronesia. There's quite a few fully trained, qualified oceanic female navigators, and they never existed before. You're not allowed to do that as a woman. But they have now. They've trained up female